This question is about isomers. Hex 2-ene has the molecular formula C6H12. Draw the displayed formula of, so displayed, got to show all bonds. Position isomer, so the functional group has to be somewhere different from hex 2-ene, and it has to exist as E and Z. So it can't be 1-ene, so maybe 3-ene. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, which puts me to there. It's got to be displayed, so I need to draw every single carbon-hydrogen bond around here. Okay, there we go. And that does exhibit EZ isomerism. Draw the displayed formula of a chain isomer. So I've got to have some sort of branching in here of hex 2-ene. So it's still got to be on carbon number 2. 2, 3. So if I put that there. So 1, 2, 3, 4. So yeah, if I have 4 there that does not exist, so 5, 6, that would do that. So I've got, and then again it's displayed, so I've got to show every single carbon-hydrogen bond as I go along here. What am I doing there? Okay, so there are one or two other options there, but I think that's probably the easiest one to get your head around. Butanal has the molecular formula C4H8, so that's an aldehyde. So with 4 carbons, skeletal formula, functional group, isomer, so it's going to be a ketone. That's the kind of standard one. It's got to be skeletal as well. So 1, 2, 3, 4, and then on carbon number 2, I'm going to do that, and there's my ketone. And then part D, draw the skeletal formula of a structural isomer of butanal that has an absorption here. So in the infrared spectra, if you look at that, you can see that this is an OH for alcohols. So I'm going to need a cyclic alcohol because I'm not going to have enough hydrogens otherwise. Okay, so, and again there are other possibilities here. So you could put a double bond in, for example. So 1, 2, 3, 4, and then there's my OH on there, and I can have a double bond anywhere along here. So I could have this. There's quite a few different ones that you could have. And then E, several saturated halogenoalkanes contain 17.8% of carbon, 3% of hydrogen, and 79.2% of bromine by mass. So let's go through and divide by the AR. So divide by 12, divide by 1, divide by 79.9. That gives me 1.48 to 3 to 0.99. You can see here this is 1.5 to 3 to 1. So if I double it, I'm going to have 3 to 6 to 2. So my empirical formula is going to be C3H6Br2. So 1 mark for the working out, and then 1 mark for the empirical formula down here. And then name of the halogenoalkanes. So yeah, just there's quite a few here. So I've got 3 carbons in a line, so I just need to put 2 bromines on any of those. So 1,1-dibromopropane, 1,2-dibromopropane, 1,3-dibromopropane, or 2,2-dibromopropane. Any 2 of those would do.